There we go. It's a beautiful Monday morning. The last Monday of February. The 24th of February, the year of our Lord 2020. Evelyn is so excited to be here. She thinks for a second. She thinks of how many hundreds of millions, if not probably a billion kids in the age group that you're in, 12, 13, 14 years old in the world. And she thinks, you know what? I had to come to school this Monday morning, but how much better off am I than all of those? I'm better off than 98% of them just by being here. So I'll rejoice and be glad, even if I didn't have that knowledge. Think about the ones that are at the low end of that have nothing, and they're still rejoicing. Right? So we'll rejoice and be glad this Monday morning, even if we didn't even have enough energy to tie our shoes on our way to school. All right. Listen, hold on to. We didn't go over the rest of that review we did last week. I know we didn't do that, but I'll try to get back to that. We've got to roll on. I'm in chapter 8. I'm on page 374. You're with me, and we're going to get a lot accomplished today. 374. Starting with the section that says getting ready to learn. This is priming the pump of knowledge, stuff that you already should know, leading to maybe there's going to be some things in the next few days that you don't know yet. Still might be things that you already do know, Micah. But this is getting you ready with, hey, remember this? Do you remember number 1? What is that? Raise your hand. What is that picture of in number 1? Be precise with your answer. Jaden?
Array?
No, close. The fact it would be a ray if it only had an arrow on one side. Jaden, it's a line. It's a line because it goes infinitely in both directions. That arrow there says that that line occupying that plane. Is anybody not clear what a plane is? It was the hardest concept for me when I was your age because all the other stuff made sense. You look at the pictures, I get it. Do you understand that that line occupies a certain plane? It's a flat, listen, the simple way to say it is this is a plane, a flat surface. Your desktop's a plane, a flat surface. A piece of paper is a plane, a flat surface. The hard part, though, is to try to visualize that there's an infinite number of these planes. So if I hold this piece of paper here and it had a line on it, if I drew a line like there is on page 374, as soon as I move this paper at all, it's now occupying a different plane. Does that make sense? Whether I move it up, down, and think about the number of possibilities there would be, because I could move it like 1/1,000,000th of an inch, right? And it would be a different plane. The weird thing about geometry is it gets you thinking how incredible, how, like, the infinite possibilities. All right, number 2, what is that? Raise your hand. Don't be shy. Come on, I know you know what it is. Come on, be courageous. Raise your hand. I think you'll get it right. Kira, it's a point. See, she didn't say it was a period or dot. She said a point. By the way, how many points are there on that line in number 1?
Oh, 0. Infinite.
There's an infinite number of points on that line. Just here to blow your mind this Monday morning. Number 3, what is that? What is number 3 a picture of, Brett? It's just an angle. It's not a specific type of angle. It's just an angle. By the way, what do we call the starting point of that angle? See where the two, oh, by the way, what do we, Jaden, this is for you. What do we call the two things coming out of the common starting point that make the angle? Rays. What's the common starting point for both of those rays called?
A point.
Has 2 unique letters in it. If you had these letters in Scrabble, you'd be really happy. It's got a V and an X in it. Starts with a V, ends in an X. What is that common starting point for both of those rays that starts the angle LP? That's called a vertex. Okay, tomorrow, listen, I didn't get this to you Friday, so tomorrow if you have a protractor, bring it. Say it out loud. If I have a protractor, I'm bringing it. If I don't have a protractor, I'm going to get one. If you don't have it by tomorrow, we'll have grace. If I don't have a protractor, I'll get one. Say that.
I'll get one.
All right. So we're not going to be able to use the protractor today, but what if I told you, look at number 5. What if I told you, page 374, number 5, raise your hand and say right or wrong. What if I told you that the angle number 5 was 80 degrees? Raise your hand and tell me that you know from your experience whether that's right or wrong. Noah.
Right.
Dominic.
Right.
Ethan. He's like, well, there's only one other choice, and Mr. Franken said no to the first 2.
Oh, I got you.
It's wrong. 80 degrees is very close to how many degrees? 90. 90 degrees would be 2, pretend those lines are perpendicular, where they meet, this would be 90 degrees, right? What's half of 90?
45.
45. So very important angles in geometry are the right angle and halfway through a right angle, which is, say it again, 45. So what if I told you that that angle was 50 degrees? Would you believe me?
Yeah.
Yes. If you have your protractor here today, you can go ahead and test that. We'll start testing it tomorrow. But that angle is 50 degrees. Number 6. What if I told you that that angle was 80 degrees? Raise your hand. Would you say, I think you're fibbing, Mr. Franken? Or would you say, yeah, it seems about right? Number 6, 80 degrees. Spencer. Why? What makes you certain that I'm wrong?
Because I'm looking at a right angle that's 90 degrees.
Okay. And number 6 is
Too far.
it's wider than a right angle. Number 6 is, this would be a right angle. It's greater than a right angle. By the way, there's no one in here that still thinks that this one is a right angle because it's going to the right, and this one wouldn't be a right angle because it's going to the left. Remember those days when you thought that? Oh, it's a right angle because it opens that way. Okay? So that's actually 120. Number 7. What if I told you that number 7 was 90 degrees? Raise your hand. Kira. Correct. It doesn't point to the right or to the left. Down, still 90 degrees. Number 8. What if I told you that number 8 was about 35 degrees? Correct. It's hard to decipher that one, but if you measured it, it's a little less than the 45 degrees right in the middle. Number 9, see if you can figure this out. Number 9 is about 60 degrees. Does that seem logical? Look at it. Number 9 seems logical. It's 60, more than 45. And number 10, who knows what number 10 would be? Number 10 is obviously not 90, but it looks like it might be 90 plus 90. It looks like if you open those rays up, 90 and then another 90. 180 degrees. So a straight line is how many degrees? Hey, let's continue this. What if we opened it up another 90? 270. What if we opened it up another 90? 360. We would make a full circle, 360 degrees. Number 11. I'll give you 30 seconds to read number 11 and tell me what you think the answer is. Shh. Focus. You trying to do that in your head? Is anybody setting up a ratio? Oh,
No.
oh boy. Just coming off the whole chapter on ratios, and nobody's setting up a ratio. Number 11. It's 20.25 inches wide and 3.5 inches long. If you're going to make a model of something, a scale drawing of something, you've got to keep the same, what's the P word? Big words, got a P at the beginning, a P in the middle. Equal fractions are called proportional. The crayon has to look exactly like the real crayon that you've blown up, like that teapot down there near the border of West Virginia and Ohio, the largest teapot. It looks like a real teapot because it's made to scale. They took a regular sized teapot and they enlarged everything the same proportion. So if this crayon is 0.25 inches wide for every 3.5 inches long, what if the crayon is in the model? What if the crayon is 6 inches wide? How long would it be? That's how you figure that out. And you know that with proportions, cross products have to be equal. So 6 times 3.5, 21 has to equal 0.25 times x, the thing that we don't know.
What's the answer?
The answer is, anybody got it?
Is it 21?
No. 21. What?
8.4 inches.
Not, you got to get your decimal point right. Think about, listen, Spencer, good observation, good time to have this teachable moment again. Could it possibly be only 8.4 inches? Because isn't the width more than twice as much, way more than twice as much as the length? So put your decimal point in the right place. How long is that enlarged?
Oh, yeah.
84 inches. So it'd be like a 7-foot tall crayon. 84. Because
What's 5?
21 divided by 0.25 becomes, whoop,
Oh, yep. Yeah.
I just multiplied 25 times like. You start the video? No.
everybody got that? Okay,
6 times. Did you start the video?
number, yes. Let's go to page 375. We've already established what a right angle is and what a straight angle is. Now we've got 2 vocab words for you. Ready? This should bring back memories. Complementary and supplementary. Say those words. If I say, wow, your hair looks really nice today, I have complimented you with an I in the middle. But if I say that these 2 angles, whoops, if I say that those 2 angles complement each other, I'm saying that if you added them together, you would get how many degrees? Complement with an E.
90.
Complement with an E. Looks like I was about to spell the word complete. They complete each other. 55 and 35 is 90. They complete each other. They complement each other. There's an E in the middle of that. Got it? A similar word to that ends the same is 2 angles that form how many degrees? 180, a straight line. We call them, everybody say it. So you've got complementary for 90, supplementary for 180. So you're going to get a lot of this in the next few days. There's a straight line, and you've got an angle like that. If you know this angle, if I told you that this angle was 45, would you be able to tell me what the other angle is without measuring it? The answer is yes. Because you know if the 2 angles form a straight line, that the total is going to be 180. So you do 180 minus 45. Everybody with me? So it's very important to know what complementary and supplementary angles do. They save you time. You don't have to measure both. It's kind of like when you learn the perimeter of a rectangle, and if you were going to redo a room and you measured the length and width of it and you knew it was a rectangle, how silly of you to go and measure the other length and width. Because if you know it's a rectangle and you've measured one length and width, you're wasting time measuring the other length and width. They're the same, right? So if you know one angle, you don't have to measure the other. You already know it. because they form a straight line. Can I hear an amen?
Amen.
Okay? Let's go down to your turn now. We should be able to do this quickly. Number 1, page 375. If measure 1 is 79 degrees and measure of angle 2 is 101, what do we call those two angles? Jaden? Supplementary, because they add up to 180. Number 2, you don't even have to write this. If the measure of angle 1 is 64 and the measure of angle 2 is 36, careful, 64 and 36. David? Neither. At first glance, you might think they added up to 90. They don't. They add up to 100. They're neither complementary nor supplementary. Number 3, Spencer. Complementary because they add up to. Number 4, Sid. Complementary because they add up to. Number 5, Bella. Neither. Again, they tried to trick you. It adds up to 100. And number 6, Lauren. Supplementary because they add up to 180. Turn the page. This one might not be as familiar to you. You learned this last year, but you might not remember this one as well. What are vertical angles? Somebody read that nice and loud. I got a little water in my ear this morning. This is no joke. Did you ever have that?
Yes.
Bothers you the rest of the day? Yeah. So I need you to read really loudly, Andrew. Read very loudly so I can hear you clearly. Kiara.
When two lines intersect at a point, they form two pairs of angles that do not share a side. These pairs are called vertical angles. And they always have the same measure.
It really isn't funny, but I was reading somebody's post. It was actually over the weekend, and the poor person was a really heartfelt post, but they wanted to say angel, and they kept writing angle. Kind of sad. It was a sad post, and then it was sad that they weren't spelling angel right. Anyway, angles. What they're saying is that when two lines intersect, these two, 1 and 2, they're not necessarily complementary or supplementary. We call them vertical angles. So, and what do we know about vertical angles? They are equal or congruent. Say that word, congruent. Because in geometry, we use the word congruent more than we do equal. Because congruent is almost the same as equal. Because both words kind of mean the same. But congruent, they have to be the same size and shape. Got that? Say congruent again. So you don't think that's a foreign word. What do we know about vertical angles? They are equal. And vertical angles are formed when two lines intersect. So the opposite angles are vertical and therefore congruent. So 3 and 4. If I measured the angle 3, would I have to measure angle 4? No. 4 has to be the same as 3. Does that make sense? Sure? All right. Let's go down to example 2, using vertical angles. Find the measure of angle 2. What's the measure of angle 2? Actually, measure of angles 2, 3, and 4. Yeah.
90.
How do you know? Now, wait. Here's what you try to do in geometry. The lazy person's going to get it wrong more than half the time on the test. You're going to try to go by what it looks like. Instead of tomorrow, we'll use the protractor. If you don't have to use it, well, let me start again. Try to go by what it looks like, and you're not always going to get it right. You have to use a protractor. But these things, vertical, complementary, and supplementary, make it so that we don't have to use the protractor more than once. Micah knows that all 3 of those angles, 2, 3, and 4, all are 90 for 2 reasons. Not really just for one. because angle 1 is opposite angle, angle 3 is opposite angle 1, and we know that angle 1 is 90 degrees, right? And angles 1 and 2 form a straight line, so we know that angle 2 is 90 degrees. And if we know angle 2 is 90 degrees, we know angle 4 is 90 degrees, right? Or either way. So that's using vertical angles and supplementary angles to answer those questions. You know the difference between perpendicular and parallel. Anybody still confused with those? Say the word perpendicular. It's kind of a fun word, isn't it? You love that word? Perpendicular, parallel. These two lines, if you can imagine that I am drawing perfectly, what do we call those? Spell the word parallel. Look at the two L's. That reminds you that parallel means they're going in the same direction, and they can go on for infinity and never get closer together and never get farther apart. What common thing do we have in our environment in Columbiana here, just down the road, that's a good example of parallel lines? Micah. Train tracks. Isn't it a good thing that the tracks are parallel? Could that be very bad if they weren't parallel? Yes. Because if they ever got closer together or farther apart, we'd have train wrecks all over, wouldn't we have them? Okay? The opposite of parallel is these guys. They are perpendicular. How do we know they're perpendicular? Because they form a right angle. So all other lines are somewhere between perpendicular and parallel. Right? These two lines running and then never get closer together. These two form a perfect 90-degree angle. Somewhere in between, I might have something like that. Where they're not parallel, they're not perpendicular. Right? Okay. Number 7 and 8. Find the measure of the numbered angles. If the angle on the top right is 137 degrees, what do you know about angle 7? Raise your hand. If the angle given is 137, what do you know about angle 7? Jonathan, angle 7 has to be how many degrees? Angle 7 has to be 137 degrees. Why? Give me proof.
Because they need to be equal.
Why do they need to be equal? Based on what? Based on what definition? Perpendicular, parallel, vertical, supplementary, complementary. What is the proof that angle 7 has to be 137 degrees? Is it because they are perpendicular? Is it because they are supplementary? Is it because they're vertical? Or is it because they're complementary? Nope, they're not complementary, because if they were complementary, they would add up to 90, and 137 is already more than 90. Yes, they're vertical. Everybody see that? Angle 8. What's the measure of angle 8? And tell me how you know that that's the measure of angle 8. I want everybody to do it at once. Let's go. Wake up. Angle 8. We definitely know the measure of angle 8 based on what we've talked about so far this morning. Angle 8 has to be, Noah? Did you write it down? Or are you guessing? Does it look like it's 45 degrees?
Yeah.
Okay. Noah, are you trying to give me like a teachable moment here? Because a couple minutes ago I said you're going to want to just try to look at it and guess the angle. There's a definite measure to angle 8, and it's not 45, but it's very close. It looks like a 45-degree angle. But I wouldn't want you building skyscrapers in San Francisco thinking, 45, whatever this is, about the same. And then the earthquake hits. Isaac,
43.
it's 43. How do you know, Isaac? Based on what knowledge?
Subtract from 180.
Why? Because they are
Supplementary.
supplementary. So supplementary angles got to add up to 180. 180 minus 137 is 43. What about the measure of angle 6? I'm sorry, 43. What about the measure of angle 6? Come on.
I'm confused.
43.
It's got to be 43. Based on what, Kira? They're vertical angles. Let's do that again, David. Ready? Angle 7 has to be 137 because they're vertical angles, David. Vertical angles are congruent. You with me? Angle 8, David, has to be 43 because if you take angle 8 and angle 37, what do they form? They form that straight line. So they have to equal 180.
What?
They form a straight line.
What form is that? I'm confused.
137 and angle 8. If you put them together, they form that straight line that goes diagonally through your page. Put those two angles together and they form a straight line, and a straight line has 180. Look at the straight line going right across the page, David. See that?
Yeah.
Okay? Do you understand that that's 180 degrees because it's a straight line?
Yeah.
Okay? Do you understand that angle 7 has to be the same as 137?
Yeah.
Because they're vertical. Okay? So what's left? If you've already used 137 with angle 7, what's left to equal 180? 43.
So you just.
Because
subtract-
180 degrees forms a straight line, you subtract them, yeah. What's left? What's needed to finish? What's needed to supplement it to make it 180? So there's two things. Either they are complementary, add up to 90, or they're supplementary, add up to 180.
How?
Or, if they're opposite each other, they're congruent based on, what's it called? Start with a V? They're vertical angles.
I know how to do it now, but I don't understand. Like, it doesn't make sense to me.
Well, keep plugging away, David, because we got one more, the most complicated, on page 377. Complementary, supplementary, and vertical. Those should be things that you already knew coming in. These are called corresponding angles. Let's say you have a diagonal line or any line that intersects two parallel lines. I need you to look at, before we go through the answers, I want you to look at 1, 2, 3, 4. See the numbers 1, 2, 3, 4 in the middle of page 377 where it says angles and parallel lines. And then I want you to look at the numbers that say 5, 6, 7, 8. I want you to be able to see, look at it, and see that 1, 2, 3, 4 look exactly like 5, 6, 7, and 8. First, look at that. Do you see that?
Yeah.
Zacchaeus, doesn't it look like we could take the numbers 1, 2, 3, 4 and replace them, just move them down to the bottom?
Yes.
Instead of saying 5, 6, 7, 8, we can number those 1, 2, 3, 4. Does everybody see that? They're exactly the same, it looks like. So, what's that tell us? Angle 1 must be congruent to angle, what? 5.
No. No.
Listen, angle 1 must be the same as angle 5. Because we just said, I said, look, first look at it and tell me that you don't see that 1, 2, 3, 4 is the same as 5, 6, 7, 8. Do you see that?
Yeah.
Look at the top cluster of numbers, 1, 2, 3, and 4. Now look at the bottom ones, 5, 6, 7, 8. Don't they look exactly the same? You can almost take the numbers 1, well you could, take the numbers 1, 2, 3, 4 and put them at the bottom part. Right? So that tells us that angle 1 must be the same measure as angle 5. They are called, say this word, corresponding.
Corresponding.
Say that again.
Corresponding.
What does angle 2 correspond to?
6.
Same as 6. What does angle 3 correspond to? 7. And the 4 could be the 8. They do what? Correspond to one another. Next definition. Alternate interior angles. We're getting more complicated here. Ready? Alternate interior angles. Angle 3, it says, must equal angle 6. Uh-oh. Why are they called interior? Inside of what?
Angle.
Inside of the two parallel lines. Is everybody following Spencer there?
Yeah.
They're well, we'll get to that. They're called interior angles because here's my two parallel lines, and when I draw my diagonal, in between the lines is inside the lines, therefore they're called interior. Outside the lines is called exterior. So they're saying that, watch, inside the lines, Jaden, interior, between the lines, inside, alternate, ready? On the left, on the, they're saying that these two angles will be congruent. They'll also be the same. Vertical angles are the same, corresponding angles are the same, and alternate, get it? Alternating on either side, interior angles are the same.
Because you could literally just flip it over and then they would be the same.
Raise your hand if you don't get it. I'll say it again. Why are they called interior?
Because they're on the inside.
Because they're on the inside of the parallel lines. They are inside. Where are my hands? Inside or outside the parallel lines?
Outside.
Where are my hands now?
Inside.
So we call them, if you're going to paint the inside of your house, you go to the hardware store and you look for the label on the paint can that says interior. If you're going to paint the outside of your house, you look for the paint that says exterior, interior, inside the lines. Alternate. What's that mean? Alternate. When you get off the bus, remember the bus safety? Did you guys do that when you're past elementary? Okay. And Mrs. Bush says zigzag or alternate as you go, right? Alternate. This side, then that side. What do we call this? Alternate interior angles are going to be congruent. The same goes for alternate exterior. Look, I'm going to call this A, and I'm going to give the marker to Cameron, and she's going to come up and put another A that she knows is equal to this A based on alternate exterior angles. Alternate exterior angles. She knows exterior. Exterior is outside the parallel lines. How'd you get so smart? Who agrees? Yeah, I said, how'd you get so smart? So you agree. Are they outside the parallel lines?
Yes.
So they're interior or exterior?
Exterior.
Is one on the left of the diagonal and one on the right?
Yeah.
So she says that this angle has to be the same as that angle.
Yes.
You get it?
Yep.
And your homework for today is numbers,
Nothing.
no, gotta be, sorry.
Numbers.
Sorry, numbers 1 through 14.
Numbers 1 through 1.
1 through 14. You got 5 minutes, go.
1 through 14.
Raise your hand if you need help. I'll come running.
What are we doing again?
1 through 14. What page is that?
378.
Complementary, they equal 90. Supplementary, they equal 180. If they're on If they're opposite each other, two intersecting lines, they're vertical. This is the hardest part. Parallel lines with the diagonal line going through them. Interior, exterior, alternate. Alternate interior, congruent. Alternate exterior, congruent. Caring more about what your neighbor's doing instead of your math,
Yes.
not good. Not a question yet. By the way, I mean, every day is a day to rejoice and be glad the Lord has made, but today, this Monday, is even more rejoiceful. It's officially OHSAA. Officially, they're allowed to have official baseball practice. You didn't react like I expected you to.
Yes.
Yes!
I'm pumped. Yay. That's awesome.
So before today, you could do workouts, but the coach couldn't, quote unquote, coach you. Now, it's official. Who's on first?
You're right.
Who goes? What's on second?
Goes there.
Stay out of the infield. He goes pick up his paycheck. Who gets it? Yes. What's the man's name? No, what's on second? You don't remember who's on first? Fifth
I'm
grade?
on first.
Oh, I remember that.
Yeah, I know.
There was a 4-year-old who
Oh, that's,
No questions yet. Everybody understands the basics of anglehood. This is very fun.
It's a fun.
This is very fun.
Yes. What do I need to do?
If you did not get the first two answers as supplementary or perpendicular, we need to have a talk.
Number one is supplementary.
It already says it's a right angle. Is that clear?
Technically, that is. Well, okay, supplementary. Yes, I see. But I put right. Now I see what you're saying.
Oh, okay.
If you did not get supplementary and complementary for answers 3 and 4, we are not off on the right foot. And our shoes may be untied.
I think my shoes are
I find way too much joy in that.
The obvious problem with the person in number 5 is they're trying to make 112 and angle 2 be supplementary. No, those don't form a straight line.
False.
Right. Angle 2 should be how many degrees?
112.
112, because they're vertical.
That's pretty smart.
Number 6 and 7, they're telling you one of the measure of angles, and they're also telling you another valuable piece of information. That in number 6, they're complementary. So you're going to subtract it from 90 to make, because you got to find out what's the difference to make up, to add up to 90. And number 7, they're telling you they're supplementary. What a great Monday it still can be for you.
You make me